All right, all right. Can you guys hear me? Nice to be here. Nice to be here. Okay. Um, just a quick survey of everybody here. Almost everyone here. Do we have anybody that does LLM here? Like you do LLM? Wow, wow. Okay, just two persons. Okay, interesting. So I think I'm gonna have to do some little explanation so that I can carry everybody along. All right, so my name is Odemakinde Elisha. Um, I'll be talking to you about BimpeAI. It's one of our AI tools that were built at Rec Labs. So a little bit about myself. I'm Odemakinde Elisha. I'm the CEO of Rec Labs Incorporation. We're based in the US. And what we do enterprise level AI for businesses. So we have a product called BimpeAI. So BimpeAI is literally chatbots for AI chatbots for restaurant owners. All right, so I just want to run through a quick demo of Bimpe, and then we'll move into the topic of why we are here, which is LLM reliability, data privacy, and security. I know that a lot of our speakers so far, since the first day, have been talking about, LLMs. So I'm not going to, go so deep about LLMs, and the likes. A lot of us have said so much about LLMs. So I just want to talk more about the security side of LLMs and then the privacy side and how reliable can an LLM be. All right. So before I go before I go ahead, you can find me on GitHub, Twitter, LinkedIn, with that at Elisha Tofumi, right? On Twitter, LinkedIn, Instagram, any platform, GitHub and the likes at Elisha Tofumi. All right, so what you're going to learn in this meeting, I want to do a quick demo of Bingpe, right? So I call it Bingpe, like the Yorubas call, a lady. It's a lady's name actually, Bingpe. All right, so I'll do a little bit of demo of Bingpe as a restaurant AI chatbot. And then we're going to talk about what exactly is LLM. I kind of suspected that we're going to be having very few people that know about LLMs. And I think my guess was right. And then we'll talk about typical LLM systems, then how are LLMs fundamentally built, how reliable an LLM can be, and things to take note as developers. All of us here are all developers, I want to believe, right? Everyone here, developers. Do you have anybody that is just new? You're new to Python. Like you're new to Python, just raise up your hand. Very new to Python. Okay. Okay, so I'll just do a little bit of brush through. So I've said a little bit about myself. So let me just watch this little demo of BingPay. So this is more or less like a chat between myself and this AI called Tommy AI. Tommy AI is more or less like a child of BingPay, right? For a particular restaurant in the UK. So I kind of decided to order rice and chicken, and then this was my conversation. This is the kind of response I was getting from it, right? So it was able to list out the costs. It was able to tell me it was able to outline the items I was trying to make requests for. I made some more additional requests, and then it was able to aggregate all those things, right? Gave me some more recommendations of what to get, right? So I told it to have plantain for me and moi moi. How many of us eat a lot of that? If you don't eat that, raise up your hand. You don't eat all of these things I'm asking for. Raise up your hand. You don't eat all these things. Okay, all of us eat. Oh, that's good. All right, so, and at the end of it, I told it to, you know, it sent me a link to make my payments, and then I made my payment, it confirmed the payment, and that was it. So it's more or less like a chatbot. So now, let's talk about why we are here, which is LLM reliability. How reliable are the systems, right? How efficient? What's the security involved? What's the risk? And all those things, right? I hope you guys are all following. You're all following, right? It's making sense. Okay, so let's get back into the slide. Okay. So what exactly are LLM systems? And this is because of a lot of people that are still newbies. I guess a lot of us still write. Some of us are very new to Python. So please, what I'll just say is just get well accustomed to it. Spend your time understanding the fundamentals of Python, introduction to Python, like lists, classes, and all those stuffs. So once you are well grounded with respect to those things, dive a little bit into data science. I'm talking to people that are practically new to Python, right? So once you've studied the fundamentals, lists, dictionaries, and all those things, dive a little bit into data science. And then after diving a little bit into data science, dive a little bit into machine learning, right? Get accustomed to KNN, then the likes, SVMs, and all those fundamental libraries. Then you move on to neural networks, convolutional neural networks, recurrent neural networks, LSTMs, attention is all you need, transformers, BERTs, and the likes. And then once you are well grounded in those things, then you can now dive deeper into what we call LLMs. LLM is more or less like restricted to languages, right, which is text data and the likes. Then we have the vision side, LVMs, right? Just as we have large language systems, we also have large vision systems for people that are into computer vision and the likes. But I want to talk more about, that's just a brief summary for those that are practically new. So I believe you took note of those things. So what is typically an LLM system? An LLM system is simply large language systems that predominantly has a lot of LLM structures, infrastructures, having communication with one another, right? That's what an LLM system is, right? And then you can also see an LLM system as a typical robot. Just picture it as a typical robot in your head, right? You can also see it as a model that understands visual data, right? Most visual data that are being fed into LLMs are fed in as patches, right? Okay, and text data. Then most of these kind of models, right, are good at encoding data and also decoding data. That's generally what LLMs are called, right? So typical types of LLMs, I'm sure you've heard of, ChatGPT, Llama, Gemini, Cloud, and the likes, right? So LLM systems can be used for language translation. Are we following? Language translation, like you're trying to convert from maybe English to Yoruba, or you're converting from English to Hausa, right? Or Chinese to Japanese. That's, you can have an LLM system that can do that. All right. Then we have typical chatbots like ChatGPT, Gemini, Cloud, Chat and the likes. Then LLM systems can also be used for sentence auto-completion or generation, right? That's why we have GPTs, generative pre-trained, transformers, right? So systems that can, maybe you start a statement and then it completes the rest. That's the essence of us having LLMs. Is it making sense? Making sense, right? Okay, don't worry. We'll ask a lot of questions. So we are getting a little bit into the interesting part, which is the privacy side and the likes. Just give me a little bit of time so that I can explain some key things. So for those that pretty much have an idea of Python, you kind of have an idea of data science, probably you're just diving into LLMs, right? So the question now is, how are LLMs built? For instance, BimpeAI was built by us at Rec Labs, and we kind of have an idea of how we built the LLM, right? So we built BimpeAI from GPT-2. So the GPT-2 weight is kind of publicly available, right? So what we did is we had to load it into our network, right? Then we had our own data set. Then we did some fine tuning and then we had to optimize it. So data sets relating to, for this Tommy AI, which was the demo you saw, right? We had sample data sets of restaurant informations, right? Conversations, right? So those were the data that we used in training BimpeAI, which was the demo that you saw. So what I'm literally trying to let you understand is that you can also build your own GPT system, right? But it's just that there's the other side of it, which is the costs side of it, hosting side of it, and the likes. Am I making sense? Am I making sense? Cool. All right. So I just want to dive a little bit about how LLMs are built, right? Simply data accumulation. You gather the data that you want the LLM to be able to learn from. Now, I had to put into bracket ethical because most data that you have to put together are data that are, ethical, data that are good, right? That it can learn from, because your model is as good as the kind of data you feed it with. Do you understand? So, but if the model you're trying to build, you're putting in some junks, you're poisoning it with some very, very bad statement, bad words, and the likes, it will learn those patterns, right? And then when it's giving responses, it starts using those poisonous words. Do you understand? All right, then another thing that is very fundamental with respect to LLMs is the tokenization, right? So literally what happens behind the hood when you feed in your text data is that the LLM system or the architecture takes the data and then encodes it into numerical values, right? Which is the tokenization side. So we have different types of tokenizations, sentence piercing, tick tokens, and the likes. So there are quite a number of other things to take note: vocab size, block size, your embedding table, right? And then there's also the interesting part, which is the major architecture behind GPTs, which is the transformer. Then we have the encoder side, the decoder side. Then, of course, you do a lot of training, right? And then you optimize across GPUs. And this thing can take sometimes days. Typical GPUs that you could use is like the A100, H100, PCLs, and SMX, right? These are kind of the GPUs that, we train on very often at Rec Labs. And of course, prompting, which is the chatbot side. You're just asking it question and then it responds. Am I making sense? Am I making sense? Don't worry, we'll ask a lot of our questions. So now let's get to the topic, right? Which is why we're here. How reliable and how efficient or how secure can an LLM be, right? This question is answerable if we can answer the following information, right? Reliability of an LLM system depends on how you give authorized access to your LLMs, right? Who are the kind of people you give authorized access to your LLMs, right? Then another thing is, how do you handle misuse of your LLM, right? Data protection. How well is the data of the people interacting with your LLM? How well is it protected, cyber threats and the likes, right? How integrity is your data, the kind of response your system is generating. For instance, in the demo I showed you, you could see that it was generating responses that made quite a lot of sense to me when I was asking it, okay, get me rice and chicken. How much does this cost? Can you add this? And it was putting all those things, aggregating everything together, and then it gave me a link to make my payment. It confirmed my payment, right? All these things has to do with how what's the integrity of, how clean, or what's the reliability of your response, right? Confidentiality handling, right? Preventing malicious exploitation. These are the things that defines how reliable an LLM can be. And of course, how do you handle large volume of sensitive information? Am I making sense? Cool. So, an LLM is completely reliable when you are able to, as a developer, right? More importantly, I know that a lot of us are still very new to LLMs. Just a few people raised up their hands. So, as a developer, you have to understand that when you're building an LLM, you have to have a good tokenization structure. You have to train your tokenizers very well. So tokenizers are one of the things that defines how an LLM understands contextual sentences. And tokenization is also one of the things that defines how an LLM is able to spell information correctly, right? I don't want to dive deep into those things, but they are very, very technical on how to actually handle that, right? Then another thing is data anonymization, right? You have to be able to encode users' information in such a way that even if you are dealing with users' information, they have to be well encoded in such a way that it's not dangerous to your GPT systems, right? So typical, legal structures or legal, for instance, OpenAI has some legal compliances that has made them very, very reliable. And that's one of the reasons why I'm making reference to OpenAI, because almost everybody uses OpenAI, or you've heard of OpenAI and the likes, right? They based in California, right? So they have the CCPA, CSA star, GDPR, SOC. These are things that they had to go through, right, in order for them to be very reliable, in order for them to be tested and trusted, right? And of course, there's always this consistent level of optimization with respect to their LLM system. All right, so let's talk as developers. What are the things to take note with respect to handling security and handling reliability in your LLM system, right? Number one, train your tokenizers very well, right? Very, very important. The beauty of your LLM is as good as the beauty of your tokenizers, right? Of course, there are online tokenizers that you can use. We have the GPT-2 tokenizers, the GPT-4 tokenizers, which is available that you can actually leverage on via tick tokens or sentence piercing and the likes. Then train on ethical data, that is, avoid data poisoning, right? For instance, avoid vulgar words when you are trying to gather your data that you want to train your LLM on, right? Don't put statements that are contradictory to the purpose of why you are building the LLM. Do you understand? Then prompt checking, validation from user, both from the input side and the output side, right? Which implies that whatever your user is feeding into your LLM, you have to kind of validate. You have to check it. Does it comply with what this LLM is built for? Am I making sense? Right. Then generalization of the problem when training a model. You have to ensure that when you're training your model is not poisonous, your model is not biased, it generalizes very well. So you're trying to avoid overfitting or some level of underfitting. And of course, you are not introducing your test data into your trained data. Do you understand? Your trained data is different from your test data. All right. User usage limits, right? Trustworthiness in model dependency, ensuring all model are dependent. That's, for instance, OpenAI does not have dependencies, right, with other third parties and the likes. So when you are building your own personal level AI, try to reduce dependency. Of course, you can build it OpenAI, right? But if you're trying to build your own personal AI, it's not that you're not trying to import from, let's say you are importing from Elisha, right? So if you're importing from Elisha, how reliable is Elisha when it comes to your own AI that you're building? Do you understand? So if Elisha is not reliable, then your LLM will not be reliable. Do you get that? Enforcing data handling and data output sanitization in cases of dealing with sensitive data, right? Then, of course, I want to rush through some of all these things. There are things that you can just take note of. These are ways by which you handle data privacy, security, and the likes. Validation of third-party plugins to reduce cyber threats. So if you are building an LLM whereby people have to use your system or businesses have to use your system, always ensure you put validation mechanisms in place. Reduce model autonomy. That is, when you are building the LLM, try and build a dashboard or build a system whereby people or there's some level of human in the loop that is kind of validating and checking that, yes, this thing is doing well as it should be. Of course, IP protection, right? using secure protocols such as HTTPS and SSL. So you have to ensure that every API calls with respect to your LLM is, verified through the HTTPS and SSL protocols. Of course, strict access control. You should be able to build your system in such a way that people that are not logged in don't have access to your GPT, so that you can basically track it and know where the issue is coming from. When training LLM, of course, anonymize the data to protect user privacy, manage and control train data sources, have a response plan when incidents like this happen. That's very, very important. If at all you are exposed to a cyber threat, you've got to have a response plan on how to handle, things like this. All right, thank you so much. And this is my conclusion. Not all LLM systems are safe and secure, right? Not all LLMs system take data privacy of optimal concern, which means you've got to check, validate to ensure that LLM systems are reliable, secure, and safe for you to use. Right? Thank you so much. I would love to take questions.
All right, thank you very much. Any questions? Okay.
Okay, thank you for the lectures. As a
Thank you.
user of LLM system, like the chatbots, how can I certify or verify that it is safe and it takes data privacy serious?
Okay, so one of the things that you have to check out for is, for instance, like OpenAI, they kind of released out documentations that explained how they handle data privacy, right? How they handle data security, right? So, for instance, you could see all those CSR, blah, 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 that are listed, GDPR and the likes. These are certification stuffs that you have to, the company has to take. And there are also third-party infrastructure platforms that, they come to vet what you've built to ensure that, yes, they are reliable for the masses that you're producing for, right? It depends if you're a B2B company or you're a B2C, but it kind of depends. But nonetheless, they still have to go through those approvals, right? So that's one of the ways by which they kind of vet on behalf of with the masses. So all we have to do is just to go and check, right, on their platform if they've been approved for such kind of operation. Yeah. Any other question? Okay.
Are you raising your hands?
He's raising his hand.
The last one.
Okay, sorry, I'm not into LLM, but I'm just curious. Based on what you said a model is as good as the kind of data you train it with. So how do you, when you get a lot of data, how do you filter out what you don't need? I'm talking like the data are a lot of them. So how do you take out the things you don't need? Do you do them manually, or is there a system that helps you do that?
Okay, so that's a very nice question actually. Datas like these, you have to go through them manually. You don't have the choice. Right? Manually is the best. Well, is as for me, as for us at Red Labs, is one of the things we do. We spend more time on our data, right, than the modeling itself. Modeling kind of have a structured way by which we build the system and the likes. But more importantly is you've got to know what the system is learning from. It's more or less like a child, right? You just give birth to a child. You have to be very careful of the kind of things you give it, right? You have to be very careful about the kind of things you expose it to. If you start exposing a child to some things that she shouldn't or he shouldn't be exposed to at the early stage of his life, you discover that the child begins to misbehave based on what you've exposed it to. Do you understand? That's just the way AI is. AI is just like a child that you are trying to feed it so much information within 3-4 hours. And you want it to be able to decide, right? Like an adult. Do you understand? So, information and the likes that you feed it with is as good as your model. Your model cannot lie. If you feed it with bad data, you have bad models. There are situations whereby you can spend thousands of dollars training a model, and it's just because your data is bad. So that's the reason why, big companies, what they do is that they spend more time on their data. They can spend 3, 4, 5 months trying to gather good data. Do you understand? And once they have those data, they validate, they check again, they cross-check. Because that's one of the things that validates your model. Your model can never lie. Do you understand? So that's the. Thank you so much for your question. Do you have any other question? Okay. Okay.
Best way to go about that
Thank you.
is to handle it manually. When you talked about data filtration,
Yeah.
so when you have large set of data going to maybe terabytes, will you manually filter out those ones you don't need?
Okay, so the thing is, before you get to large chunks of data, you would have started with 1,000. Then from 1,000, you move to 10,000. Then from 10,000, you move to 100,000. You've already validated 100,000. You've already validated 1,000. Before you move to 10,000, right, you are already validating. So the thing is, for a company, they don't just pick 10 million data. They just say they are just training like that. They start with smaller chunks, but they have a lot of data annotators. They have a lot of data validation companies that they partner with. Those people have chunks of people that looks into this data, that follows those standard procedure. So the data they've looked into already satisfies the static discipline. So any other one that they are bringing in, right, is to ensure that those ones also satisfy the static. It's more or less like you are just appending. So what you've done last year, you are not going back to it again. You are going back to the one that you are dealing with right now. Do you understand? So that's it.
All right.
Thank you very much.
Thank you. So next we have happening in the PSF room. We have real-time